So, good evening, everyone, those who are in India and who are joining me live on my YouTube channel. Today, we'll be talking about MYP Sciences, the written curriculum. Okay, so let me first open the waiting room so that anybody who wants to come can join, right?
Yes.
Okay, so day before yesterday, we looked at the aims of the MYP Science curriculum, and we saw how the standards and practices help us to develop the curriculum or the aims of the particular subject, right? So now today we will go to the written curriculum, and I remember someone had asked like, how should you decide what are we going to teach in the MYP Sciences? So today we'll focus on that. So I've used the science guide, MYP Science Guide, as well as Claude and Gamma. So these AI tools I have used. With the help of the subject guide, I've created this presentation for today. So let's go and know more about what the written curriculum should look like in MYP Sciences. Okay. So when you look at the aims of MYP Sciences, we have these aims that we looked at in the last session. If you want, you can have a look at the previous live session where we spoke about the aims of MYP Sciences. So let's recapitulate a bit. Uh, According to MYP Science, what we need to do is that you need to increase scientific literacy, help the students to appreciate the complexity and the diversity of the natural world. You need to develop inquiry skills by giving them hands-on experiences to do investigation as well as experiment. You need to develop their analytical skills, their critical thinking skills, and know more about scientific claims and the evidence. Because we are looking at IB philosophy in the curriculum, so you need to encourage international mindedness, build an understanding of global scientific challenges, and also you need to promote responsible citizenship. So you have to develop awareness about environmental and ethical issues in science. And we do it through the different science subject objectives. Okay, so these aims are met. So going to the objectives, the learning objectives are same as the assessment objectives. The assessment objectives are also named according to the learning objectives. So the first objective is knowing and understanding, where the students need to demonstrate knowledge and understanding of scientific facts, principles, concepts, laws, and theories. In objective B, the students should be developing skills to design and carry out scientific investigations. For objective C, the students should know how to collect, process, and interpret qualitative and quantitative data. So processing and evaluating are the skills that we are looking at. And in objective D, the students will reflect on the impacts of science. So here we will connect real life experiences and issues while studying this particular objective. So students will understand the applications and implications of science in society. So these are the main objectives of sciences in the MYP. Now, what are the program requirements? Program requirements are very important because if they are not met, you get a matter to be addressed. Okay, so what are the program requirements? The teaching requirements are that for each year of the MYP, there has to be minimum 50 hours of teaching. And if the school goes for MYP e-assessments for sciences, then the minimum hours go to 70 hours. Okay, so minimum teaching hours should be 70 hours for e-assessments for MYP 4 and 5. And for MYP 1, 2, and 3, it has to be minimum 50 hours of teaching time. Also, the requirement is that you have to have balanced coverage of physics, chemistry, and biology across the 5-year program. Okay, and you have to teach the curriculum according to inquiry-based learning. So the pedagogical approach should be inquiry-based learning. What are the assessment approach that we are looking at in the MYP? There has to be a variety of practical work. In the types of assessment, there has to be a variety. You just can't have only tests. Okay, students should be able to do experiments. They should do research projects. Of course, they will also have tests that they need to take, especially in criteria A. So these are the different types of assessments that the students will be doing. Also, the global contexts have to be integrated while assessing so that the learning is relevant and meaningful. So therefore, these are the 5 important program requirements. Minimum hours, 50 hours for 6, 7, 8, grade 6, 7, 8, 70 hours for 9 and 10 if you're doing e-assessments. Learning has to be inquiry based. You have to include global context. There has to be a balanced coverage of physics, chemistry, and biology. And there has to be a variety of types of assessments. Okay, so these are the program requirements. Any questions?
Yes, ma'am.
Yeah,
Ma'am,
deputy.
here, so if the school is going for discrete sciences,
Hmm.
so that will come into play only in MIP 4 and 5, right?
When I am talking about how to organize the subject sciences, that time I'll be talking about what should be the topic and how you should be teaching it. Okay, so we will come to that. Uh, Now, when you are teaching sciences in the MYP, you also have to keep in mind that we are also doing interdisciplinary teaching and learning. Okay, so there has to be some interdisciplinary planning and there has to be connections with the other subjects also. So, though the core curriculum focus is sciences, how do we connect to mathematics? When in math, students are studying about data analysis, graphing, mathematical modeling. So in scientific context, so that is a time where you can do interdisciplinary unit with mathematics. What about language and literature? How do you connect learning with sciences? You need to teach them how to do scientific writing, okay, and communication. How do you communicate? And research skills. Okay, so these are taught through language and literature. In individuals and societies, what aspects are you looking at where you can make connections? Ethics in science, different environmental issues, especially when you're doing geography. Okay, and when you're doing history of scientific discoveries, of course, you will look at orientation in place and time with INS. Okay, now how do you connect in design? There will be opportunities when you are doing engineering applications or when you are going to study technology in scientific research. Okay, there you can make those connections. In arts, specific scientific illustration, if you have to do creativity, creative communication of scientific concepts, so you can use arts at that time. Physical and health education, it is very easy to connect with biology, human biology, with sports sciences. You can do nutrition, you can do organ systems, especially skeletal system and uh, muscular system. So that is the scope for connecting and doing interdisciplinary planning. Okay, so these are the different ways where you can do interdisciplinary plannings and connect with other subjects. So now, when you are teaching through the MYP, MYP 1, MYP 3, and MYP 5, if you look at the subject guides, you will have the progression of the objectives. So when you look at the project progression of the objectives, year 1, that is grade 6, what are we looking at? In objective A, you're looking at basic factual knowledge, where students can recall scientific facts, they can use scientific vocabulary, and they can show understanding through simple explanation and examples. Okay, so we are looking at basic factual knowledge. In objective B, where you are looking at guided inquiry, okay, designing experiments. So here students will write research questions with the guidance of the teacher, because maybe the students don't know how to come up with a research question. So they will be guided by the teacher. They will follow simple methods, okay, with teacher support. They will write the procedure with the help of the teacher, and they will identify basic variables with the help of the teacher. So if you see over here, it is guided inquiry. The teacher helps the students with the inquiry, with the lab investigation. In objective C, also over here, you will be giving them chance for opportunity for basic data handling. So the students will be able to collect and record data in simple formats. They should be able to identify patterns in the data, and they should be able to write basic conclusion from the data that they observe, from the patterns that they observe. Okay. In objective D, where you are looking at scientific impact, the student should be able to identify some ways where science is used in our daily life. And they should also recognize the basic positive and negative impact of science. Okay, so this is for year one, MYP 1. Now in the guide which you see, after year 1, they have given year 3, okay, grade 8. In that, you're looking at, in criteria A, there is deeper conceptual understanding. Here, students will explain scientific concepts, and they will apply knowledge to solve simple problems, and they will make connections between the different science topics. Here in objective B, they will try to become independent inquirers. They will formulate research questions with minimum guidance, but still here students may need some guidance. Okay, so depending upon the level of independence they are in. Students should be able to design methods with some independent thinking, and they will be able to identify and explain variables more confidently in grade 8. And about data processing, they should be able to process numerical and visual data, and they should be able to identify the trends and patterns more accurately than what they were doing in MYP 1. In objective D, the students should be able to discuss implications of scientific developments, and they should also consider ethical dimensions of the different scientific applications. So here you see that you go a little higher than MYP 1 if you're looking at the objectives. And in MYP 5, remember here, the students should be ready for the diploma program. So if you are doing backward planning, then look at the objectives here, where in criteria A or objective A, the students should analyze complex scientific information. They should be able to synthesize knowledge, okay, and they should be able to evaluate theories and models critically. So problem solving questions they should be able to answer. Here in criteria B or the objective B, the student should be able to write independently the research question, and they should be able to write the design the methodology, okay, and think about what different control variables or different independent and dependent variables they would consider for the experiment. In objective C, the student should be able to analyze data more sophisticated by using sophisticated processing techniques. Okay. They also have to look at evaluating reliability and validity of the data, how valid the data is. So here, the number of trials have to be similar to what they are going to do in the internal assessments in the DP. Okay, students should be able to draw well-supported conclusions, and they should be able to show their proper understanding of what is actually happening. Okay, in objective D, they should be able to analyze different implications of the scientific developments. They should be able to evaluate about the scientific applications, argue about the positive and negative impacts, and also give reasoned solutions to any science related problems. So now here you see that the students are becoming independent learners in grade 10. Okay, so you have the objectives for grade 6, grade 8, and grade 10. And these objectives are similar to your assessment objectives. Okay. So now how does the progression of objectives take place across the years, across year 1 to year 5. So here you have the diagram where year 1, you are giving guided skills and knowledge to your students. In year 2, you are developing the inquiry and basic analysis. Year 3, you will start applying the concepts and the students are becoming independent. Year 4, you will be giving them complex investigations and they will be able to evaluate critically. Okay. And in year 5, they will do independent synthesis and they will have their own inquiry. So students will be able to write their own research questions and come up with a properly designed experiment. So if you see over here, the sciences curriculum is designed with a clear progression path where you start from basic guided learning in year 1 to becoming independent learner in year 5. Okay. So very often in the MYP, you will hear about these two words, horizontal planning and vertical planning. So what do you mean by horizontal planning and how does it look? So suppose if I'm going to take this one example of MYP 1, grade 6, and if I'm going to study patterns in nature in this particular unit, so then when we have to do horizontal planning, so in sciences, I'm studying classification systems, life cycles, weather patterns. And maybe in mathematics, the students are doing data collection and graphing and basic statistics. In language arts, the student will be learning about descriptive writing. Okay. And in arts, you can look at scientific drawing and nature photography. So if you can see over here, there are certain skills that are taught in other subjects where you can use in science. Okay. So this is how horizontal planning takes place. So the content as well as the skills, you map them so that you are not teaching content uh, in isolation. You will need to take help from the other subjects in order to make your disciplinary understanding stronger. Okay, so this is one example. Now in grade 8, year 3, sorry, MYP year 3, if we are going to study sustainable communities, then in sciences, you can look at studying about ecosystem interactions, energy transformations, and material science. In chemistry, so what could you study in design? You can look at sustainable technology solutions. In language arts, you can look at persuasive writing about environmental issues. And in individuals and societies, you could look at urban planning and economic impacts of sustainability. So here easily you can do an IDU if you're going to teach these topics in the different subjects. So I can start with horizontal planning based on the topic that you're teaching. Okay. Also, there are skills that you can learn through the different subjects which are needed for sciences. If you're looking at year 5 example, MYP 5, and if I'm going to do the unit on innovation and progress, then maybe in sciences I'm looking at genetics, quantum physics, and advanced chemistry. Okay, maybe organic chemistry, where you are looking at producing nylon and looking at hydrocarbons, uh, distillation, fractional distillation of petroleum, if I'm studying that, organic chemistry. Then in mathematics, I could be doing modeling and complex data analysis. Uh, Philosophy could be a part of INS. You're looking at ethics. And in arts, your visual representation of abstract scientific concepts. You can study this and you can look at an IDU. So when you're looking at horizontal planning, one is thinking about IDU. What are the skills that, and also thinking about ATL skills. What are the skills that we are teaching in the other subjects which will help uh, learning of sciences as well? I'm sorry for hearing. So sorry, I have someone at the door and my dog is busy barking. There's a gift from Madhvi. She told me that she's sending one. Thank you, Madhvi. And she's absent today because there is no electricity in her house.
I'm there.
Oh, you're here. Your gift has arrived. So Yankee was busy barking at the door. Thanks.
She's
I have
checking
to.
now.
Yeah, Yankee is checking it for me. Okay. Let me continue. So we were looking at 1 minute. Let me go back. Okay. Sorry. Okay. So we were here. So when you're looking at horizontal planning, there are two things to consider. Number one, whether you can do an IDU and what are the other subject teachers doing. Okay. And another thing where you can look at horizontal planning is your ATL skills. Okay. How the ATLs are being taught. So you can look at that in the horizontal planning. Now about teaching. This was the question that Debjyoti, you had asked, right? What was the question?
Yes, ma'am. So my question was precisely for year 4 and 5, I think the schools can go for the discrete sciences. But
Hmm.
what do in that case, if they are not going for integrated sciences in year 4 and 5,
Hmm.
in that case, what do they do in year 1, 2, and 3? Do they go for can they go for like a discrete science in year 1, 2, and 3 itself, or they go for an integrated science through that modular science format? Um,
We do modular science. Okay, I will tell you the difference between how you can
right,
do it.
right.
Okay, but
Okay,
first
right.
let us study. Let us go through how you progress from MYP 1 to 5 in terms of three different subjects. Okay,
Sure, sure.
physics,
Okay.
chemistry, and biology. Because
Yeah, sure.
ultimately you have to get the students prepared for diploma program, right? Because after MYP they will go to DP, and in DP Group 6 you have physics, chemistry, biology. You also have ESS, Environmental Systems and Studies. You also have SEHS, Sports, Exercise, Health, right?
Health
Sciences.
science. Right.
So then what is the way forward? How are we, progressing in terms of teaching and learning of the subject matter? Okay. So if you're looking at biology across the years from MYP 1 to 3, in MYP year 1, you should see that you are teaching the basic needs of living things and simple classification. In MYP 2, you should look at animal and plant structures, basic genetics. MYP 3, you can look at ecosystems, food webs, cell structure. MYP 4, you can look at human body systems, evolution concepts, and MYP 5, you can look at molecular biology, advanced genetics, and biotechnology. Now, this is just an example. I'm not saying that teach this. Okay? Yeah? It can be different. The topics can look different, but this is one suggestion. Okay? Now, in chemistry, what you can do is year 1, you can teach properties of materials, states of matter. Year 2, you can look at chemical and physical changes, basic reactions. Year 3, you can look at atomic structure, periodic table, introducing that. Year 4, chemical bonding, reaction types, and in year 5, organic chemistry, thermodynamics, and kinetics. Now, again, this is a suggestion. Okay. In physics, this could be the progression. You go from down to up. Okay. Year 1 is forces and motion, basics, light, sound. Year 2, energy types, transformation, simple machines. Year 3, electricity and magnetism, wave properties. Year 4, nuclear physics, introduction, electromagnetic spectrum. Year 5, quantum mechanics, concepts, and relativity introduction. So this is another suggestion for physics. Okay, so you can look at different topics and you can teach. Okay, the teachers know best who are teaching in that particular school. So as a department, you need to sit together and you need to think about what are we going to teach, because MYP is a framework, it doesn't give you the curriculum, but you can look at the MYP science guide. Over there you do have the topic lists, you have the key concept, related concept, global context. Okay, uh, you have separate topic lists for physics, separate for chemistry, separate for biology if you're going to teach discrete sciences in MYP 4 and 5. And you also have the topic list for integrated sciences. So you as a school decide how you want to teach and what do you want to teach for your students. Okay. Now, you have the MyIB teacher support materials. Those who are in the IB, they need to have this particular login, okay, for MyIB. And when you look through the teacher support material, you will find the subject guide there. Okay, you will find assessment exemplars, samples. Okay, the graded, marked with the rubric. Okay, you will find the unit planning template. You will find tools for developing investigation skills. Okay, and in the from principle into practice as well, in the subject guide you will find global context materials. There are examples of how global context can be taught in the different topics in sciences. Okay, so these all materials are available for the teachers, so please take effort to go through the resource materials over there. Okay. Now, when you have to do unit planning, then what do you need to look at? Okay, you have to start with your objectives first. What objectives are you going to, teach or assess in that particular unit? You choose the relevant global context. You choose the relevant key concept, related concepts. We will do a whole session of how to do unit planning in our next session. Okay. I'm giving you a brief description of how unit planning takes place. You go through the inquiry cycle. Okay. You help the students to design inquiry sequences. You think if you are going to assess criteria B and C, which is for lab investigation, then you have to think about learning experiences that you are going to teach students so that they develop those skills, and then you do a summative assessment on the same criteria, same objective. Okay, so you plan your formative assessments. There are examples in the teacher support material to guide the teacher how to create those assessments. And in the unit plan, there is a section for reflecting, okay, for teachers. At the same time, you also need to give opportunity for the students to reflect on their learning. So before doing a particular task, when they are doing a particular task also, and after they finish their summative also, if you can give a reflection sheet to them, it's a good idea. Also, a reflection sheet for them to self-assess their ATL skills. So before teaching, developing that skill, you can ask them to grade themselves, and then after learning their skill, they can reflect and see that how they have grown as a learner in that particular type of skill that was being focused in that unit. Okay. Now, how are you going to use the resources in MyIB? You adapt the materials which is there, especially for criteria A. Criteria A tends to be a very difficult criteria to, create the question paper for all the strands that are there. Okay, so in the teacher support material for electromagnetic induction, there is an excellent criteria A assessment which is there, which you should refer to, and it will give you an idea of how to create a criteria A assessment. Okay, so though it is physics, you at least you will get an idea of how to create a criteria A paper. Okay, so look at that example, use rubrics And when you are using your rubric for any criteria, it is mandatory to write task specific clarification. Okay. And you build your resources according to the year level. Work with colleagues. Now, when we are talking about colleagues, it's not just in your school. You have this platform, the global classroom, where now you can see already there are science teachers over here. I can see Alicia, I can see Pooja, who is here. Of course, she is a science teacher, that's why she is here today. Swaleha is here, Madhvi is here, Debjyoti. Debjyoti, you to know Madhvi because you did the trainer also with us. So we can easily connect and you can share your plans or your tasks and ask for feedback, right? And you can review the unit plans regularly because as they update the MyIB, they update some resources also in the teacher support material. Okay, so when you're using the science materials, look at your specific context. Okay, don't take it as it is. Think about, maybe if that question is too difficult for your student, then what have you taught and what will they be able to do? Okay. Make sure to keep in mind the main goals of the program. What are the aims of the subject? Okay. And working with other teachers will also help you to ensure that you are consistently talking about the language that is used in the MYP. Because if I talk about, okay, approaches to learning skills, how did you teach critical thinking skills? And if you're not using the language, then students will not understand, and you will not be teaching the MYP. Okay, you need to use the particular terminology, like how in sciences, when we say photosynthesis, all biology teachers and students will understand what photosynthesis is, right? Because it's a common language that we'll be using the vocabulary. So same way, there are certain terminologies in the MYP which you should consciously use it, and students will not be able to understand, or if we ask them, okay, what learner profile are you showing, if you don't give examples of it and show it explicitly or teach it explicitly in your classes, right? So you have to make use of those terminologies so that your students also understand and they make use of those terminologies. Yeah. How are you going to integrate technology? Um, in some experiments where you cannot do it, okay, physically, then you can use virtual labs. You need to make use of data logging tools also, because this is used in the DP. And unless and until you start using it in the MYP, students will not know what they are. So maybe MYP 4, 5, start using data logging tools. You can use simulation software. Okay, and this was very helpful, especially during COVID, when students could not go to the lab and do experiments, right? So it does help. Uh, have digital portfolios, the task that their students are doing, have it digitally so that it is easy for you also to track the student progress, and use collaborative tools. So there are learning management systems, ManageBack, Toddle, that you use. At the same time, if you are Google Apps for Education School, then you could use Google Docs, Google Slides, where students can collaborate together. You can share and they can do their tasks collaborated together. They don't need to be in one place in order to do that work. They can share it online and collaborate and work together. Okay. So now, bringing it all together for today's session, what did we look at? We looked at the objectives of the subject. The learning objectives of the subjects are same as the assessment objectives. Okay. Knowing, inquiring, processing, reflecting, criteria A, B, C, D. Okay. Then what are the subjects that you're going to teach? You're going to teach physics, chemistry, biology, sometimes earth science, sometimes ecology, okay, life science, but basically physical science and life science. Then connections, how do you make connections horizontally? Interdisciplinary links through global context, through ATL skills. And the progression is very important. You should have year 1 to year 5 scope and sequence of what you are going to teach. in the three branches of science. Yeah, so these are all the things that I wanted to explain, but also about organization of sciences in the school. Okay, for this, we know that you have core sciences. If you look at the subject guide, you have like this, right? You have physics, chemistry, biology, and you have integrated sciences. Topic lists are given in this way, right? But then there are additional options, maybe in NGSS, the American curriculum. If you see, they have health sciences, earth sciences. Okay, so you may have these additional options also. Okay. So the discrete science courses are, separately, teaching physics, chemistry, and biology separately. And some schools, when they offer discrete sciences, remember that you have to offer 70 hours each for those discrete sciences. That means 70 hours for physics, 70 hours for chemistry, and 70 hours for biology. Okay.
Ma'am, I have a question.
Okay.
Um,
You'll have to
Ma'am,
be louder because cannot hear.
hello.
Huh.
Ma'am,
Yeah.
in the subject guide, it is written that subject group must address all strands of all four objectives at least twice in each year of MYP.
Mm.
Can you explain me that?
Yeah, that I will do it. Okay. First, let us look at this.
Okay.
Just remind me that question. Okay. So for discrete sciences over here, if you are going to teach physics, chemistry, and biology, number one, you have to give 70 hours each for each of the discrete sciences. Okay. So most schools, what they do is they ask students to choose any two sciences. Okay. So you could do physics, chemistry separately, or you could do chemistry, biology separately. You could do. Okay. So, another thing that you have to keep in mind is that you have to use related concepts from the course's disciplinary focus. Okay. So, if you look at the subject guide, I will show you what I mean. So, if you look at the subject guide, and if you look at the related concepts. Okay, so these are the related concepts. Okay, so the definition of all the related concepts are here. Control F. Page 60. Huh. So if you look at the related concepts here, if you are going to do biology related concepts, okay, so all of these 12 related concepts have to be addressed in the 2 years of MYP that you are teaching, or in the 5 years of sciences that you are teaching. Okay, you cannot miss out on any of these related concepts. If you're looking at chemistry, then all of these related concepts have to be taught in the 5 years of your sciences curriculum. Okay, and in chemistry you have this, and in integrated sciences you have these 12. So if you compare the integrated sciences with the physics, chemistry, biology guide related concept. So wait, what I do is So this is my document, okay, where I have all the key concepts of all the subjects here. This is my document when I'm doing my evaluation preliminary review, okay, because I'm a PL. I have to sit and check, right, all the subject group overviews. So I have written all these things. So I have to check all the subjects, right, as a PL. But if you look at the related concepts, see, I have written integrated over here, but because most of the schools that I have evaluated right now, they did integrated sciences. So I just have the integrated sciences here. But if I look at balance, consequence, energy, environment, and if I look at if I compare, okay. So balance is there in bio, it's there in chemistry, but there is no balance in physics, right? Okay. Environment, it's there in biology, it's there in chemistry, it's not there in physics. Can you see?
Yes, ma'am.
So the related concepts are missing. If you're going to teach discrete sciences in grade 9 and 10, please don't just use these related concepts. Check for these specific related concepts also which are missing if you're going to do discrete sciences. So if you're going to do discrete sciences in the MYP 4 and 5, for your grade 4 and 5 SGOs, please ensure that if I'm going to do biology, that these are there, okay? If these are not there, especially now what is there here but not there, consequences, evidence, environment, function, interaction, models, movement, patterns, transformation. So if I look at it, okay, the integrated sciences and the biology fits in perfectly. It's same, okay. But if I look at integrated sciences and physics, chemistry, okay, what is missing? Chemistry has conditions. Your integrated science doesn't have conditions. So make sure that in MYP 4 and 5, if you are doing chemistry, discrete sciences, you have the related concept conditions there. If it is not there, matter to be addressed, I will give you. Because this concept is not, addressed in your scope and sequence if you're going to do discrete chemistry. Did you understand, everyone?
Ma'am, yes, ma'am.
Okay.
Ma'am, I have a question over here.
Yeah.
So we can see the separate RCs over here,
Hmm.
and this means for the discrete sciences
Hmm.
as well as for the integrated and the modular sciences, right?
Correct.
Now,
Correct.
now in MIP 1, 2, 3,
Hmm.
if the school is offering an integrated curriculum
Hmm.
prior to going for the discrete sciences in MIP 4 and 5,
Hmm.
so how do we look at it? Means what I'm trying to say is at the onset itself, should we decide that okay, from MIP 1 itself we'll go for complete bifurcation of sciences? Maybe not
Good
going for
question. Good question.
discrete
Okay. Okay.
sciences.
1 minute. I have an answer to that. So then what you can do is you can do modular sciences like how I taught. Okay. Though I said integrated sciences because it was physics, chemistry, biology all together. Actually, I taught modular science. Okay. So if you look at MYP integrated science Weebly, okay, I did not actually teach integrated sciences. I taught modular science because if you look at the grade 6 units over here, okay, first semester I taught physical science. Second semester I taught life science. Okay, so you can see measurements is physics, speed, distance, time physics, force and motion physics, energy transformation. I can do physics and chemistry both, right?
Right,
Okay,
ma'am.
heat
Right.
energy transfer physics. Okay,
Mm-hmm.
states of matter chemistry. Yeah.
Mm-hmm.
biology, life science.
Mm-hmm.
Can you see that?
Yeah.
So
Yes.
though I'm saying integrated sciences subject, actually it is modular science. I'm teaching one semester physical science and one semester life science. Okay. Again, if you look at grade 8 topics. Density and pressure physics, electrostatic chemistry, electricity physics, chemical reaction chemistry, rate of reaction chemistry, है ना? Photosynthesis, reproduction, microbes, genetics, all bio.
Mm.
And if you
Mm.
look at the curriculum also, whether you look at IGCSE or whether you look at MYP, the biology content is much more than physics and chemistry.
Yes.
है
It's
ना?
always ma'am like that. Yeah.
So that's why there is more bio
Yeah.
than
It is
physics and
always
chemistry.
right.
Even when I was teaching ICSC, chemistry
Mm-hmm.
was like very less in grade 6, 7, 8.
Yeah.
Okay?
Mm.
Yeah, Prapti, you have a question.
Hi, ma'am.
Hi.
Happy Teachers' Day to you, first
To
of
you
all.
too.
Thank you. My question is, as Mr. Debajyoti was also saying, if we go for discrete sciences from MYP 1 itself, but when we introduce sciences, we have, let's say, the key concept, related concept, and global context as similar, but under that, we teach physics, chem, and biology as separate sciences with separate classes. Does that work?
Okay. Then, okay. It is not just teaching your subjects, right?
Yeah,
It is
right.
also about what Madam Madhvi has asked question. Okay. For every objective, every strand, you have to assess twice, minimum. Okay. So think about the topics that you are going to teach, units that you are going to teach. Think about how many assessments you are going to take. Are you understanding?
Yeah.
So, and in other subjects like language and literature, language acquisition, earlier when I was MYP coordinator, I used to say language acquisition, 4 units a year. You will not believe now in the same school that I was coordinator earlier, now they are doing only 2 units a year in language acquisition. So my question was that if you're only going to do 2 units a year and in each unit you have criteria ABCD, are the students going to do only one assessment? One summative assessment, and what if they were absent student?
Exactly. So I that's why then in that context it still helps to have 4 units and making sure that it is physics, chem, and biology. If it is just sciences, integrated sciences, we could have summative assessments with 4 units. But if it's physics, chemistry, and biology, wouldn't it be okay to have 2 units then? We reduce the amount of assessments that students take in the year, making sure that we address the objective twice, minimum twice in a year.
See, you can teach it however you want, okay, and whatever you want. MYP never tells you कि you teach it this way and you teach it that way. Your context, okay, at your school, what you want to do. The main thing, what is the requirement is you should have taught physics, chemistry, biology, okay. You should have 50 hours requirement, okay, and the students should be ready for DP. So my question is, if you are going to do too much, I don't have many lessons to give. If you're going to do physics, chemistry, biology separately, you'll need 50 hours, 150 hours. Do you want 100? Are you able to give that much in the timetable? No. If
Nine,
you're
right.
not, Prapti, that is the problem. And if I'm going to say physics, chemistry, biology separately in MYP 1, 2, and 3, that means you're going to give, if I give only 5 lessons for integrated sciences. So are you
Mm-hmm.
going to give 1 lesson less to the physics teacher?
Mm-hmm. Right.
Huh?
That's a
2 lessons
confusion.
physics, 2 lesson chemistry. If then
Yeah.
bio, are you
Yeah.
going to give me only 1 lesson?
One
And you
lesson.
saw
Yeah.
that in bio, how many units are there
Right.
compared
Right.
to physics and chemistry? Then how
Right.
are you going to do that? How are you going to
Manage.
do the
Yeah.
justice?
Yeah. So my question also in the chat, what the other question also I asked was, so ideally, if you're doing physics, chem, and biology, how many classes should the week have? If you're doing
So
integrated,
in
then
the three IB schools that I have worked, and in the Cambridge also where I'm working presently, we are giving, if we are doing physics, chemistry, biology, it is 2 lessons, so 6 lessons a week out of 40. But if it is MYP, integrated science, we give only 5 lessons. So 2 double lessons, 1 single lesson. Now, why double lesson? Because if I have to do a criteria C and a D, I need a double lesson to do a lab investigation. I cannot finish it in a 40-minute class.
yes, yes, very true. Yes,
Okay. And if I have to give a summative assessment, I need to have 80 minutes at least. I
right.
cannot finish it in 40 minutes.
True, true, very true.
So 2 double lesson, 1 single lesson. So I'm thinking in terms of a coordinator also, how I'm, you know,
Pacing out.
scheduling, or how am I putting the number of lessons also in a week.
Right, right. Okay.
Okay.
All right. Yes.
So you have to think about all these things, not just think as a teacher.
Mm-hmm.
Okay. Are you all aspiring to be coordinators? If yes, then think about those things also. Don't just think about your subject. Ki, I need 2 lessons and I need 3 lessons. Nahi, Baba, look at the whole picture. I cannot give 9 lessons for sciences and give only 4 lessons for PE. Because in the MYP, all 8 subject groups have equal weightage.
Right.
है ना?
Yes,
So how
yes.
is it fair to have for sciences to have 9 lessons and only 4 lessons for PHE and
PH.
design?
Yeah, yeah, works.
Okay.
Mm-hmm. Yeah, that
Yeah,
is
the
true.
coordinator speaks.
Yes.
Devjyoti, you have a question.
Yes, ma'am. So, what I can sum up from your point of view is that for year 1, 2, and 3, we can take the modular sciences route,
Mm,
right? Like
mm,
five classes a week
mm,
across year 1, 2, and 3. And when it
mm,
goes to year 4 and 5,
mm,
we can take the discrete science route where
mm.
we can have 6 classes a week because
You
does that
don't have
mod
6 classes a week for each of this. You can
no,
have
no,
six
no.
classes, but you could do two, two, two. So you say
Two,
integrated
two,
sciences. You say
two,
integrated
2
sciences.
plus 2.
Two physics, two chemistry, two biology. Only the problem here is you need a lot of collaboration between the 3 teachers, because
Science
you are also
teachers,
looking
yeah.
at those assessment objectives. How are you fulfilling those assessment
Mm-hmm.
objectives? Okay, there's a
Right.
lot of collaboration needed.
Mm-hmm.
Okay, I
Yeah.
cannot say only physics is important or bio is important. Yeah.
Right, right. Yes.
Hmm?
And ma'am also, yes, ma'am.
Hmm.
And ma'am, also one more thing. Uh, so I have heard this thing that in case of integrated sciences, when they do integrated sciences for year 4 and 5 and they write the assessments, still there is a quite a lot of gap in, so when they go for DP subjects.
Yes.
That is a very sensitive area I know I'm getting into.
No, no,
So
no, no.
is,
I have a solution for that. Don't worry.
yes,
Ask a question.
so in that case, uh, what is your take on this? That if you keep the DP in mind, that
Mm,
okay, a child, say from a batch of 20 students, at
I
least say around,
understand.
you understood, right, what I'm trying to
Yeah,
say? Like
yeah, yeah. So
less
if
than
I'm going to
50%
do
will go for
HL, if I'm
HL.
going to do
Yeah,
HL bio, and if I have
right.
not taught genetics, then how am I going to do? Okay, because my basics
Exactly.
is missing.
The depth,
So
the depth,
nobody is telling you not to
rigor.
teach. Nobody is telling you
Right.
not to teach. Okay, I have
Mm.
taught genetics, Punnett square. You teach it in grade 9 and 10
Honest
for
score. Yes,
IGCSE,
yes.
right? I have taught in grade
Mm.
8.
Mm-hmm.
So you look at your curriculum, right? MYP, nowhere it's written that you can't teach extra or you can't
Mm-hmm.
prepare students for DP. You plan your curriculum accordingly.
Right, right. Okay. Understood.
So
Okay.
if you are finding gaps, fill those gaps. And nobody is saying that you can teach only those topics in grade 9 and 10. You can teach it in grade 8.
Okay. And ma'am, in year 4 and 5, when they do a lot of experimental works and so forth, do you feel it's a good idea to introduce some elements of DP to them, that okay, to create a linkage, that okay, once we say not in the beginning of the year, maybe like after say 1 or 2 months when they have got some hang of the curriculum, how to progress through it, that, okay, see, this is the connection
You will
between
be
MYP.
teaching it. You will be criteria B and C automatically internal
Exactly.
assessment.
Exactly. B and C
Huh.
internal
Yeah.
assessments. Right.
And if you do criteria D, automatically TOK will come.
TOK, reflection, yeah,
Huh.
reflecting
Yeah.
on the impacts of science, yeah. Okay, makes sense. Okay, thank you.
Okay.
Yeah, thank you.
See, I told you, I have an answer. Been there, done
Yeah,
it.
yes, ma'am, I understand. Thank you.
Okay. So, Madhvi, uh, when you say that all the assessment criteria, all the objectives have to be assessed at least twice. So, if you're looking at your subject guide, okay, if you're looking at the assessment criteria, in assessment criteria A, how many strands are there? Can you share your this subject guide?
Criteria A, ma'am.
Hmm.
4.
4 strands, है ना?
Hmm.
नहीं, let you know it because you are teaching in the MYP. Na, let Madhvi share her subject guide. Those people who don't know, subject guide share कर. नहीं है? Okay, let me share.
Should I share, ma'am?
नहीं है इधर.
Ah.
Okay, subject guide.
And now I'm able to, I was locked. I was not able to minimize my screen only.
हो रहा है? चल दिखा तू. ले, कर. Because your subject guide is your Bible. If you don't know which pages and what, then I don't know what you are reading. हाँ, रुक. हाँ, इधर लिखा है ना? बोल्ड में. This one you are saying, right? That's a requirement of the program. That's why it is in a box. And if this is not met, you get a matter to be addressed. Okay? So go down. So if you look at the science criteria here, scroll a little, knowing and understanding. So can you see the Roman points 1, 2, 3? They are called as the strands.
Okay.
Okay? So criteria A, knowing and understanding, has 3 strands. First strand is outline scientific knowledge. Second strand is apply scientific knowledge and understanding to solve problems set in familiar situations and suggest solutions to problems set in unfamiliar situations. And strand 3 is interpret information to make scientifically supported judgments. Okay, that means in your question paper, you should have questions for all these 3 strands. Okay, and you should have questions for all these 3 strands for different levels. Can you see level 1 and 2? So in level 1 and 2, these strands, can you see the command term?
Yes.
Select, apply. So that means you have to give questions where you select, where the student selects scientific knowledge, where they select and suggest solutions to familiar situations. Okay, and they apply information to make judgments with limited success. This is level 1 and 2. Now again the same strand, if you see 3 and 4, the command term has changed. Recall, apply. So that means you have to give questions of this level for the 3 strands. Okay. Now look at 5 and 6. Again the command term has changed. The first command term has become state. Then apply. Okay. And if you look at the second one also, earlier it was suggest solutions in 3 and 4. Now it's become solve problems. Can you see the complexity?
Yeah.
The questions have become more difficult. And the last one for 7 and 8, it is outline scientific knowledge, apply scientific knowledge and understanding to solve problems in familiar situations as well as unfamiliar situation. If you see 5 and 6 is only familiar situation. 7 and 8 is familiar as well as unfamiliar situation. Okay. And 7 and 8, the last strand is interpret information to make scientifically supported judgments. So why I'm telling this question paper of criteria A is difficult because you have to give questions of all the three strands for the different levels of questions. So if I'm going to create so many questions, okay, think about the time that the students will take. And in one unit, are we able to give all the strands on all the questions?
No, ma'am, that is not
So that's
possible.
why it is difficult.
Ma'am, so is it a mandate that in particular one question only all these levels has to be covered?
So that's
No,
why
no.
Debjyoti, that's why I said that look at that electromagnetic induction wala criteria A ka assessment in the teacher support material.
Yes,
It is
ma'am,
an
understand.
excellent example of criteria A assessment.
Right.
Okay, refer to that question paper. You will get the answer to your question, and then you tell me the answer after you read it. Okay, so next time when we start our session, first you will do that.
Okay, ma'am.
Huh?
Yes, ma'am.
Okay.
Yeah, done, ma'am.
I will not forget, huh, Debjyoti.
I know I will
We
not
got
forget.
homework to do now.
I know I
Of
will not
course,
forget,
if you're
ma'am.
going to come for a session, I will give homework.
Yeah, ma'am, definitely, ma'am. I will complete it.
So
Surely.
when you do your homework, then only you'll remember, right? You'll not forget then.
Yes.
Your MYP Science.
Yeah.
ठीक है?
Yes,
So
ma'am.
today's session, did everybody understand what is the gist? Okay, tell me your takeaways. Okay. All of you, if you are doing MYP the first time, where did Sri Lakshmi disappear? जब takeaway आने को आया तो she's disappeared. Okay, give me your takeaway. Your aha moment for today. I know some of you must have taught for a few years the MYP. Some of you must be teaching now, or some of you are planning to teach ahead. But I want your takeaways for today's session. If you're coming here, you will have to share your takeaways. Okay, who will go first? Who will be a risk taker? See, I'm using IB terminologies.
Me,
Debjyoti,
ma'am.
go ahead.
Yes, ma'am. Ma'am, for me, the key takeaways are the curricular progression that we can have from year 1, 2, 3, 4, and 5, because in the guide it says very explicitly about the year 1, 3, and 5. But 2 and 4, they have not mentioned
Correct.
explicitly. So where you have given for biology, physics, chemistry, all the clear-cut topics as a guiding light. So that was a very interesting thing for me and very useful thing for me.
And also, nobody tells you you can't refer to the Cambridge lower secondary curriculum. Okay,
Yes,
I
ma'am.
agree that I'm not a curriculum specialist. Okay, but I have taught CBSE, I have taught ICSE, I have taught Cambridge, I have taught GCO level, and bio is bio, right? Whether it is CBSE, ICSE, cell will be cell only, right?
Yes,
So refer to the different curriculum. Those curriculum syllabus, they are created by experienced curriculum designers. Okay. So nobody tells you, just give that acknowledgement or credit that you have taken from this particular curriculum. Hai na? And then you also
yes.
have new generation science, NGSS
NGS.
of
Yeah,
American curriculum.
yeah.
Yeah, look at those also. Take the
Right,
best from everywhere. Yeah.
right. Makes sense. Thank you.
Okay, takeaway next. Who is going to share their takeaway?
Yes, ma'am. Alfisha this side. Good evening, ma'am.
Hi, Alfisha.
Ma'am, I have learned about the biology progression chart. That
Mm-hmm.
was very helpful for me. Like for year one, what we can teach from year one to year five.
Mm-hmm.
That was helpful for me.
So you teach MYP?
MYP 4 and 5 biology.
Okay. All right. So,
Yeah.
okay. All the best. So you need to collaborate with your teachers and see backward planning. Otherwise, what will happen, the MYP 4 and 5, DP will say that, MYP 4, 5 did not teach anything. And 4, 5 teachers will say, MYP 1, 2, 3 did not teach any skills. Okay. And then MYP 1 teachers will say, PYP didn't teach any skills. So please collaborate and, as a team, look at the content as well as the skills that you're going to teach in sciences. Yeah.
Okay, sure.
Pooja, you want to add your takeaway?
Ma'am, wishing you all a very happy Teachers' Day.
Happy Teachers' Day to you too.
Yeah, first of all, when the session started at 7 o'clock, things were going like Greek and Latin for me.
Mhm.
Yeah, as I don't have any IB background.
Okay.
But then slowly and steadily, as you were explaining, I started getting, I started understanding a few parts, and I was really happy when you said that biology is biology, whether you teach any curriculum. And the collaboration part, which you said that you can collaborate with teachers of various curriculums, various grades, and you can understand. So I'll be very happy if anyone wants any help, or I would be very happy to learn from their experience. And if there's anything, kind of collaboration that I can do with anyone,
So
more than
Pooja,
happy.
what curriculum do you teach right now?
Right now, I'm working in CBSE schools.
Okay. So whatever I teach over here or whatever strategies I share, please implement it over there. It's not that you can't implement. It's best teaching practices that you do, that you learn. You know?
Yes. So I would like to take that ahead and say that before a few months you had shared a list of tools, AI tools, and the websites that you can use in classes for teaching science. In fact, it was a entire array of various subjects collaborated in which all tools you can use. So
Mm,
I tried using a few of them in my class, and Padlet worked
mm.
very well with my students. They were so happy. After the lesson was completed, I used to create questions and they used to go home and solve them, and I
Oh,
could
wow.
see responses over there. So they themselves were so happy because we were doing how do organisms reproduce in grade 10.
Okay.
And that is a chapter where kids have a lot of questions,
Mm,
but then there is always a fear that मैं कैसे क्लास में पूछूं ये.
yeah. Understood.
So that gave them an open platform where they could, actually come up with questions, and kids really came up with very good questions. In fact, in the
Oh,
classes also, they used to give me cheats where they used to write down their questions, and they used to, wait for the answers. Okay, what is the answers? When is Miss going to come up with the answers? So it was really very nice.
thank you. Thank you. It's so nice to hear that, these teaching practices help you make the students more engaged in their learning.
Yeah.
Yeah. So thank you for your share. Omakshi, you have anything to share? Your takeaway for
Yes,
today?
ma'am. Yes, ma'am. Thank you for today's presentation, ma'am. Ma'am, I learned related concept how they are different in the integrated science, and how
Mm-hmm.
if it is discrete one, and how
Mm-hmm.
it changes when number of hours changes when we teach in integrated
So
science.
you
And
teach the MYP, Omakshi?
yes, ma'am. Yes, ma'am.
Okay. Which grade?
Ma'am, MYP 1 to MYP 5.
Oh, okay. All right. All right. Okay. Anything
Thank you,
else
ma'am.
that you want to share?
No, ma'am, this much only.
I hope it was not information overload to all of you all. Okay, Madhvi, you want to share your takeaway?
Yeah, for me, it was a complete session. It was like an overview, getting an idea about how the progression happens, and then about how you said about the related concepts, how it needs to be covered throughout the MYP years.
Mm,
Plus, in the logistic wise, how you have to divide the number of hours and make sure that it has to be met.
mm.
So, yes, complete.
And I answered your question.
Yeah, but I need to see how practically it happens, so it will take some time.
Yeah, yeah. Okay, okay. So, thank you everyone for coming for this session. Do subscribe, like, share, comment on this live video. You will find this video on my YouTube channel, Ashika Tenzin, the Techie Teacher Mentor. It will be there. I will just put some description on this live video. And yeah, do give me feedback. Do write your comments on the video on the YouTube to share with other people who are interested in sciences. Yeah, and it's not only for sciences. When you go through the subject guide and look at the learning objectives and all that, you will also relate it when you are teaching the other subjects.
Yeah, we can
All
always
the things.
transfer that knowledge.
Yeah, you can transfer the knowledge. Good. So another thinking skill transfer will be taken care of when you watch this video and share it with your other colleagues. So thank you so much for coming to this